What if I told you that the word off, as it applies to your voice assistant, does not mean what you think it means? Not because the companies are lying to you in any legally actionable way, but because the technical architecture required for a voice assistant to function at all makes the lay definition of off impossible. The microphone, for the device to do its basic job, must be listening. The question is not whether it listens. The question is what it does with what it hears, what gets stored, what gets transmitted, and how often the line between a false wake and a deliberate capture gets crossed in your home without your knowledge. I want to walk through the actual mechanics of this because the discourse around voice assistants has oscillated for a decade between two extremes. On one end, the dismissal, they're not really listening, stop being paranoid. On the other, the panic, they're transcribing everything and selling it. The truth is more interesting and, frankly, more concerning than either position because it sits in the uncomfortable middle where the system works as designed. And that design still produces outcomes most users would not accept if they understood them. Start with the wake word detector. Every major voice assistant, Alexa, Google Assistant, Siri, and the various third-party smart speakers and vehicle assistants uses a small, low-power machine learning model running locally on the device to detect a specific phrase. Alexa, hey Google, hey Siri. That model is looking for a very specific acoustic pattern. It does not understand language. It does not transcribe what you say. It essentially asks, moment by moment, does the last 2 seconds of audio sound enough like my target phrase to trigger the rest of the system? For that to work, the microphone must be active. A small rolling buffer, typically a few seconds long, must exist in RAM. The local model runs continuously over that buffer. This part is uncontroversial and well documented in the technical literature published by the vendors themselves. Amazon, Google, and Apple have all written about their on-device wake word detection architectures. Where it gets complicated is the false positive rate. No wake word detector is perfect. The model is tuned to balance two errors. Miss the wake word when it was said, and the assistant feels unresponsive. Trigger on something that wasn't the wake word, and the assistant wakes up, records, sends audio to the cloud, and responds to a phantom command. Vendors tune toward the second error, toward more false wakes, because a missed wake is a visible failure to the user, while a false wake is often unnoticed. Research has quantified this. A study out of Northeastern University and Imperial College London, published in 2020, tested popular smart speakers against hours of television programming and conversation to measure how often they falsely triggered. Their findings were striking. Across different assistants and models, the device is activated unintentionally somewhere between 1.5 and 19 times in a 24-hour period, depending on the device and the content playing near it. Some false activations lasted several seconds before the device realized the command didn't make sense. During those several seconds, audio was being captured and, in many cases, transmitted to the cloud. Expand that finding to a real home. If your smart speaker falsely activates 10 times a day, and each false activation sends 5 to 10 seconds of audio to a remote server, that is roughly 1 to 2 minutes per day of unintentional cloud-transmitted household audio. Over a year, that is hours. Hours of conversation, argument, television background, moments of personal silence, moments someone said something they would not have said to a recorder. None of it was triggered by the user deliberately. All of it ended up in the same cloud infrastructure that handles deliberate commands. Then there is the human review pipeline. In 2019, a series of investigations by The Guardian, Bloomberg, Vice, and others revealed that Apple, Google, and Amazon were at that time using human contractors to listen to and annotate voice assistant recordings as part of their quality improvement processes. The recordings the contractors heard included unmistakable false wakes, conversations that had no wake word, intimate moments, business conversations, and, in some cases, content that suggested domestic abuse or medical emergencies. The contractors had no consent relationship with the people whose voices they were hearing. Following the reporting, the companies changed their defaults. Apple paused human review and later restructured the program to be opt-in with explicit user consent. Amazon added an opt-out. Google did the same. The programs were reframed around user consent. The fundamental architecture, however, did not change. Audio still gets transmitted. It still gets stored. Whether or not a human listens to it depends on your account settings, which depend on defaults that can shift over time and across jurisdictions. Now let's address the off question directly. When you mute your smart speaker using the dedicated mute button, what happens? On most mainstream devices, muting electrically or logically disconnects the microphone from the processor's audio input path. The mute button is not just a software flag. It's designed to be a hardware-adjacent cut, verified by reputable teardowns and by vendor documentation. Amazon, for example, has specifically documented that on Echo devices, the microphone mute button disconnects the microphone circuit, and the red indicator light that accompanies the mute state is driven by the same circuit, making it harder to spoof. That is genuine, and it is the strongest form of off you can achieve on these devices short of unplugging them. But it comes with two caveats. First, you have to remember to mute and unmute every time you want to use or silence the device. Almost no one does this consistently. Second, the mute only applies to the dedicated voice assistant microphone. Many voice-enabled devices have secondary microphones for other features, such as stereo calibration, or, on newer models, for detecting acoustic events like glass breaking or smoke alarms going off. Those secondary microphone pipelines may not be cut by the assistant's mute. On smartphones, the situation is worse because there is no equivalent hardware mute switch. Your phone's microphone is controlled by software. Operating system permissions can prevent most apps from accessing it, but the voice assistant, being a first-party system service, operates at a privileged level. On Android, Google Assistant's Always Listening feature, when enabled, keeps the low-power hot word detector running. On iOS, Hey Siri operates through a dedicated low-power coprocessor, so that always listening is possible without draining the battery. Apple has published fairly detailed security documentation about how this coprocessor interacts with the main system, and the design is relatively privacy-conscious, but the fundamental precondition, a microphone always hot enough to detect a wake word, is intrinsic to the feature. Then there are the accidental microphones, smart TVs, set-top boxes, game consoles, connected appliances with voice features no one uses, car infotainment systems, smartwatches with voice assistants. Each of these represents another microphone in another location, running its own wake word detector, subject to its own false wake rate, reporting to its own vendor's cloud. Samsung smart TVs, in a privacy policy from a few years ago, famously included language warning users not to discuss sensitive topics in front of the television, because captured audio might be transmitted to a third-party transcription service. Samsung subsequently revised both the policy and the underlying behavior, but the episode illustrated how the attack surface spreads across categories people do not associate with voice assistants at all. A separate and worse category of risk involves malicious or compromised applications. A number of research papers, most notably work from the Smart Auditor Project and related academic groups, have demonstrated techniques called voice squatting and skill-based eavesdropping, where third-party voice app developers can craft invocation names that sound like legitimate commands. A user says something they think is triggering a built-in function. Instead, a malicious third-party skill activates, and because the skill is running in the voice assistant's platform, it can capture the subsequent audio interaction and exfiltrate transcripts. Amazon and Google have policies against this, and they enforce them through skill review. But review is imperfect, and new techniques emerge faster than review updates. On a different axis, vehicle voice assistants and aftermarket smart car modules have become a quieter frontier for this kind of concern. Several documented cases have surfaced where vehicle telematics systems captured audio that was later retrieved through legal discovery. The devices were not sold as recording tools. They captured audio for voice command processing. The recordings were retained anyway, on vendor infrastructure, under policies the drivers almost certainly did not read. Let's talk about what you can actually do, without pretending there is a perfect answer. The strongest mitigation is removal. If you do not need a voice assistant, do not deploy one. The Echo Dot you received as a gift and never really use is not neutral. It has a microphone hot in your home. Unplug it, put it in a drawer, and the surface area collapses to zero. If you want the convenience and are willing to accept some risk, choose vendors whose architecture is most transparent and whose mute implementations are hardware level. Review the privacy settings. Disable voice recording retention. If the option exists, most major vendors now offer this, with Alexa and Google Assistant allowing you to set recordings to delete after a period, or to not save at all. Disable the human review opt-in. Understand that the device will still transmit audio during interactions, but the persistent archive shrinks. For phones and computers, disable always listening wake word detection entirely. On iOS, you can disable Hey Siri in settings while keeping Siri usable by button press. On Android, you can disable Hey Google, or remove Google Assistant's microphone permission while still using voice typing on demand. This shifts the model from always listening to push to talk, which is a meaningfully different privacy posture. It reintroduces a small amount of friction. That friction is the point. For smart TVs and similar devices, check the settings for voice recognition features and disable them. Most of these features see extremely low usage rates. The manufacturers enable them, by default, because they demonstrate a capability, not because users asked for them. For the genuinely high-threat model users, researchers, lawyers handling sensitive cases, journalists with confidential sources, the correct architecture is to keep voice assistants out of the work environment entirely. Conversations that matter happen in rooms without internet-connected microphones. The pattern underneath all of this is a familiar one in the privacy conversation. Convenience features require data access. Data access requires trust in the vendor's architecture, policies, and future decisions. Trust requires the ability to verify, and verification is almost never available to end users. What we are left with is a landscape of devices, whose functions depend on capabilities their users cannot audit, producing accidental data flows their users cannot see, governed by retention policies that change with corporate priorities. Off as marketed is a reassurance. Off as implemented is a spectrum. The most private state is unplugged, and the second most private is hardware muted, with retention disabled and wake words turned off. And everything else is a negotiation with a microphone that has never stopped listening. Not once, since the moment you first welcomed it into the room.